Hello friends, welcome to the channel Physics by IITians. In this video, we are going to discuss a very important question from electrodynamics. This question will be helpful and the concept discussed here will also be helpful in the upcoming exams. If you find these videos helpful, please like this video, share with your friends, subscribe to our channel. So let's start the question. Question is very simple. You have been given a vector potential capital A, that is A y square x cap. So it is in x direction and it is dependent on the y square. A is some constant. Now you have to find what will be the current density and the charge density in that particular region. So whenever you find a question that is connecting the charge density and the current density, that you can see that you should use some Maxwell equation where there is a charge density rho and there is a current density J. Then you can also see there is a vector potential coming into the picture. So whenever you see a vector potential term, you should always focus on the two equations that connects the magnetic field with the vector potential and the electric field with the vector potential. So let me first write what I am talking about. Firstly, an important equation that the magnetic field is equals to the curl of A. This is the first equation that you should always focus whenever you feel a vector potential is given. Then for the electric field, you can say electric field in any region is equals to negative of gradient of phi minus del A over del T. So the second equation will help you to find the electric field and the first equation will help you to find the magnetic field. But then you will say the question is asking you to find the charge density and the current density, and I am talking about the electric field and magnetic field. So this is not a nonsense. Actually, if you can find the magnetic field and the electric field, then the fourth Maxwell equations will help you to find the other parameters. How to find the rho, the charge density? You can say use the first Maxwell equation, that the divergence of electric field is equals to rho. Then if you know the magnetic field, you can use the fourth Maxwell equation. What is that? The curl of the magnetic field is equals to J. There is some del D by del T term is also there, but you will see that that term will be 0 because the field will still be 0. There is no scalar potential given to us. That means we can assume that phi is 0. There is no scalar potential. Also, the vector potential that is given is only a function of y and it is directed along the x direction. There is not a time factor here. That means this del A over del T term is also 0. So you can directly say that first term is 0 because there is no scalar potential. Second term is 0 because the vector potential is not a function of time. So your electric field will come out to be 0. So in this region where we are finding the charge density and the current density, the electric field is 0. And if the electric field is 0, then its derivative with respect to time will also be 0. So that's why I am writing curl of B is equals to J as the equation. Okay, so now we know that the electric field is 0. So if I use this equation that the divergence of E is equals to rho, then you can directly say that rho will also be 0. So there is no charge density there. So I can say rho is equals to 0. So first thing we have already calculated. Now our question is to find the current density. So we have to use this equation 1 that I have written here and the equation 4 that I have written here. How can we use these two equations? So I have B is equals to curl of A and curl of B is equals to J. So if I take the curl of this first equation, both the sides, so what you will have? You will have curl of B is equals to curl of A. Right? Now, curl of B is known to you. It is the J that you want to calculate. So you can substitute this curl of B as J. And this is a vector identity that you can use. And the vector identity will give you this is negative of del square A plus divergence, just a moment, yeah, plus gradient of divergence of A. This is the vector identity that you can use. Okay, so this will give you the J. let me write this equation as equation number 5 and let me clear the other portion of the screen. So first thing we have calculated, rho is 0. Now we have to simplify this equation 5 to find the j. Okay. Let me clear all these equations. Okay. So we have j is equals to negative del square a plus del divergence of a. So let's first find what is the divergence of a here. So a is given to us as a y square x cap. And if you see what is how we define the divergence of any quantity, so divergence is like this is a del operator, and this will operate like x cap del by del x plus y cap del by del y plus g cap del by del g dot with the vector quantity a, and that is given to us as a y square x cap. So if you find this dot product first, this second term and the third term, y cap and j cap will not give you any dot product because there is no y component or the z component of the vector field, vector potential. So this will only the first term that will survive. So you will say that the divergence of this a is x cap del by del x of this whole quantity a y square. Again, you will see that a is a constant and this is a y square, and you are taking a partial derivative with respect to x. So you cannot get any quantity here. This is just a 0. That means divergence of your vector potential is 0. So the second term in this j equation or the equation number 5 is also 0. So now we are left with that j is equals to negative of del square a. So that we need to find further. So let me again clear this portion of the screen. So this is important that this del square, considering this factor, is a very important thing. So let me write it carefully. So we are finding that j is equals to negative of del square a, and that is equals to negative of, remember this del is not a vector quantity and a is a vector quantity, so I can write del square as del 2 over del x square plus del 2 over del y square plus del 2 over del g square times the vector potential a, that is a y square x square. Okay, let me clear this equation 5 now, because now we have left with only this particular equation. We have to carefully see each and every term of this equation because there is a chances of error here. So what is the chances of error? First, see this factor. This is a del 2 over del x square, and it will be multiplied by this particular term a y square x cap. X cap is just a direction, so it will give you that the j that is coming to be, means whatever be the current density coming, that will come in the direction of x, that we know. Now this is a derivative with respect to x, and the a is only a function of y. So this first term and this first term cannot give you any finite quantity. So this will give you 0. Same logic you can apply for the third term. This will also give you 0 because this is a derivative with respect to z and this is not a function of z. Now let's focus on the second term. This is a derivative with respect to y and the vector potential is also a function of y. So this can be finite. So let's see. So it is negative of, now a factor you can, okay, let me write it carefully. So it is del 2 over del y square a y square x cap. A is a constant that you can keep outside. So it is negative of a double derivative of y square. So that will be 2y is the first derivative and that 2 is the second derivative. So it will just give you 2 x cap. So your j, the current density is negative 2a x cap. So that will be the answer for this question. The current density is negative 2a x cap and the charge density is 0. I hope you understood each and every part of this question and how we systematically solve this question. If you understand it and you like this video, please like to the video and you can share it with your friends. Please subscribe to our channel. We have a test series that is going on for the CSIR NET exam, and you can join this test series. That will be very helpful for your upcoming exams. And also we have an interview guidance program that is helpful for the upcoming interviews and also to clear your basics for the physics of different topics. Thank you.